Okay, so for the review, the first problem is basically kind of using a square root method in a way. So first thing you want to do here is isolate or get the x minus 5 all squared by itself. So the first thing I'm going to do is subtract the 9. I end up with 3 times x minus 5 all squared equals 24. And now when I divide everything by 3, or both sides by 3, I end up with x minus 5 all squared equals 8. Now remember, to get rid of the exponent 2, I take the square root of both sides and I get x minus 5 equals plus or minus the square root of 8. Now remember, square root of 8 can be simplified, so that's going to break up into the square root of 4 times the square root of 2. So when I add 5 to both sides, I will end up with x equals 5 plus or minus the square root of 4 is 2 root 2. This would be your exact answer. You should be able to take those two decimals on your own. So give the exact answer and then know how to find the decimals. So the next one, you're going to use the square root method again. First thing you want to do is isolate the x squared term now. Get that by itself. So I'm going to add 10 to both sides to make that happen. Oh, add 10. So 5x squared equals 55. Then divide both sides by 5. X squared equals 11. To undo the exponent 2, take the square root of both sides, and you end up with x equals plus or minus the square root of 11. So when you go to do number 3, solve the quadratic by factoring, first thing you want to do is set it equal to 0. I'm going to subtract 28 from both sides. So x squared minus 12x minus 28 equals 0. So now I got to find the numbers that multiply to give me negative 28, add up to negative 12, and that would be x minus 14 times x plus 2. And you should know it's just the opposite of the constants in there, or you can take each factor, pull it out, set it equal to 0, add 14. So one solution would be x equals 14, subtract 2. The other solution would be x equals negative 2. Okay, to solve by completing the square, if I have x squared plus 14x equals 60, to complete the square on these two terms, I'm going to take half of 14 and square it. So I'm going to get x squared plus 14x plus 7 squared is 49 equals 60. And remember, whatever I add here, if I'm going to the other side, I'm going to add the same amount. So add 49 there. This quadratic expression will become x plus 7 all squared equals 109. Now I can go ahead and take the square root of both sides. X plus 7 equals plus or minus the square root of 109. And if I subtract 7 from both sides, x equals negative 7 plus or minus the square root of 109. 109 cannot be simplified, so leave as is. Number 5. First thing I have to do to solve it using quadratic formula is set it equal to 0. So I'm going to add 3x squared to both sides, subtract 6x from both sides, and I end up with 8x squared minus 8x minus 6 now equals 0. So I can go over here now and find the discriminant. So negative 8 squared minus 4 times 8 times negative 6 will give me a discriminant value of 256. So now the quadratic formula, the opposite of negative 8 is 8 plus or minus the square root of 256 all over 2 times a, which is 8. So that gives us 8 plus or minus the square root of 256 is going to be 16 over 16. Now, this breaks up into two solutions. One is going to be 8 plus 16 divided by 16, which gives you 24 over 16. And that right away, both of these can be divided by 8, so that would give you 3 over 2, or 3 halves. And the second one would be 8 minus 16 over 16, which will give you negative 8 over 16, which is negative 1 half. Okay? So those would be your two solutions. Now remember, the discriminant can tell us the number of x-intercepts, the number of solution, and the basically nature of the x-intercepts. So when I evaluate the discriminant for this first one, right, you remember discriminant is b squared minus 4ac. So 1 squared minus 4 times 2 times 2, right, this discriminant will have a value of negative 15. And right away, that's going to tell you there's no solution, right? And if there's no solution, that means there's no real x-intercept. Okay. The next one, my discriminant would be negative 9 squared minus 4 times 4 times 2. So this discriminant, when you plug it in, would have a value of 49. And since the discriminant is positive, that means you're going to have 2 real solutions, which means you're going to have 2 x-intercepts. And the last one here, your discriminant would be 6 squared minus 4 times negative 3 times negative 3. And that discriminant would have a value of 0. And remember, if the discriminant is 0, there's 1 real solution, which means the vertex is on the x-axis and there's 1 x-intercept. Okay? Number 7. When you go to solve these quadratic inequalities, basically you want to find where your x-intercepts would be first. So this, I look, is it factorable? And the answer to that is yes. X plus 4 times x minus 3 is greater than 0. What values of x make this equal 0? That would be negative 4 and positive 3. So if I go over to the number line, I'm going to go to positive 3 and to negative 4. And I'm going to use 0 as a test point. I can plug 0 into either one of these equations. I feel the first one's easier. So, does 0 squared plus 0 minus 12 make a true statement? Is it greater than 0? The answer to that is no, which means you will not use the shaded region in between. Now, if I choose a test point outside, it would make it true, and outside it would make it true. So in this case, we're going to say in interval notation, we're going to go from negative infinity to negative 4. It's a round bracket because you're not including it, unioned with 3 to positive infinity. Now the next one, you can use quadratic formula, you can use, factoring to find the x-intercepts. So I feel factoring is going to be the easiest way here, but again, if you use quadratic formula, you get the same thing. So how does this factor? If you use AC method or the x method, you would get 2x plus 1 times x plus 6 is less than or equal to 0. So what value of x would make this equal 0? That'd be negative 1/2. What value of x would make that equal 0? Negative 6. So if I go to my number line, you have 0, you have negative 1/2, and then you have negative 6. Right? So if I use 0 as a test point, is 2 times 0 squared plus 13 times 0 plus 6 going to be less than or equal to 0? And is 6 less than or equal to 0? No. So you know right away, anything out here or out here will not work. So your solution is going to exist right in between these two values. So we say on the left side we start at negative 1/2, so square bracket because you're equal to negative 1/2. Negative 6. Right on the left side, comma, negative 1/2 is where it ends. Okay. Number 8. To add these complex numbers, 4 plus 2 is 6. Negative 3i plus 6i gives me plus 3i. The next one, if I distribute the minus sign, that becomes plus plus negative. So negative 4 plus 8 would give me 4. Negative 5i minus 12i is minus 17i. Next one, 3i times 4 is 12i. 3i times 2i is going to give me plus 6i squared. We don't want to leave it as I squared, so what does this become? 6 times negative 1. So 6 times negative 1 is negative 6 plus 12i. Number 11, negative 2i times 3 is negative 6i. minus 2i squared, but this becomes negative 2 times negative 1, so that's going to become positive 2 minus 6i. Done. 12. 5 times 1 is 5, minus 15i. Remember, you got to kind of FOIL here. Negative 2i times 1 is minus 2i. And negative 2i times negative 3i is plus 6i squared. Now this becomes minus 6 because 6 times negative 1. So 5 minus 6 is negative 1. Negative 15i minus 2i is minus 17i. When we're squaring this complex number, 2 minus 3i times 2 minus 3i would give me 4 minus 6i plus 9i squared. This here would become negative 9. 4 minus 9 is negative 5 minus 12i. When we go to multiply in 14, multiply 9 minus 6i by its conjugate. So 9 minus 6i times its conjugate would be 9 plus 6i. So right away, 9 times 9 is 81. The last terms will give you minus 36i squared, which ends up being 81 plus 36, which right away turns into what is that? Sorry, brain freeze here. That would be 117. Alright, number 15. Because it's kind of like a monomial, I'm going to multiply numerator and denominator by I. That would give me 3i minus 2i squared all over 4i squared. Now, negative 2 times negative 1 is going to give me positive 2 plus 3i all over negative 4. And if I look at this, you could kind of read this one of two ways. One answer could be if I divide everything by negative 1, I would get negative 2 minus 3i all over 4. Or you could basically get negative 2 over 4 minus 3i over 4, which would result in negative 1/2 minus 3i over 4. Okay. The next one, I'm going to multiply the numerator and denominator by the conjugate, which is 3 plus 2i. So 5 times 3 is 15 plus 10i when I distribute the 5. And when I multiply the denominator by its conjugate, 3 times 3 is 9. Negative 2i times 2i is going to give you minus 4i squared. This becomes 9 plus 4, which would be all over 13. So I would take that answer, but then you could break it up into 15 over 13 plus 10i over 13. Done. Number 17, I'm going to multiply numerator and denominator by the conjugate, 3 minus 4i. Up top, I am going to have to FOIL. 2 times 3 is 6, minus 8i, minus 3i, plus 4i squared, all over. Again, when you multiply the denominators, you can FOIL it out. But you should recognize by now, if I do 3 times 3, I get 9. 4i times negative 4i is minus 16i squared, which becomes 9 plus 16. So that would be over 25. Now I do have some simplifying to do up top. This could be 6 minus 4, which is 2. Then negative 8i minus 3i would give me minus 11i. All over 25, which is 2 over 25 minus 11i over 25. Alright. Number 18, first thing I'm going to do is set it equal to 0. Add 10. I end up with x squared minus 10x plus 10 equals 0. Right away here, if I go to use quadratic formula, because it's not factorable, I can complete the square if I want. It's actually probably easier, but a lot of you are probably going to resort to quadratic formula. So if if I find the discriminant, negative 10 squared minus 4 times 1 times 10, it's going to give me 100 minus 40, which is 60. Whoops. Now, x equals, the opposite of negative 10 is 10, plus or minus the square root of 60, all over 2 times 1. Now, what they're going to want you to do here is they're going to want you to give the exact form. So I do have to simplify root 60. When root 60, remember, is root 4 times root 15. So you would get 10 plus or minus 2 square root 15 all over 2. And since all of these can be divided by 2, 10 divided by 2 would be 5, plus or minus 2 divided by 2 is 1, so it's square root of 15, over 1, which just ends up giving you 5 plus or minus square root of 15. Now if I did complete the square on that, I would add 25 here, then negative 10 plus 25 on this side becomes x minus 5 all squared equals 15, square root, square root. I would get this, add 5, boom, x equals 5 plus or minus the square root of 15. So anytime you can complete the square, sometimes it ends up being easier. Alright, the next one. Even if I factor out the GCF of 3, it won't be factorable. So we're going to go ahead and find the discriminant, right, which is negative 3 squared minus 4 times 3 times 9, which is going to give me a discriminant of negative 99. Right away, you know you're going to get, right, a non-real root. So x equals, the opposite of negative 3 is 3 plus or minus the square root of negative 99 all over 2 times 3. Now, when you simplify root negative 99, it's going to give you root negative 1 times root 9 times root 11. This is going to translate to 3 plus or minus 3i root 11 all over 6. All of these coefficients and constants are divisible by 3, so I'm going to divide everything by 3 to get 1 plus or minus I square root 11 all over 2. Alright, and that's your answer. You can write it as 1/2 plus or minus I root 11 over 2 also. Now number 20, the last one here. Subtract 3 and you would get negative 6x squared plus 3x minus 1 equals 0. It's not going to end up being factorable, so I go right away to my discriminant again. That's going to be 3 squared minus 4 times negative 6 times negative 1, and it gives you a discriminant of negative 15. So, two non-real solutions, so right away I'm going to get the opposite of 3 is negative 3 plus or minus the square root of negative 15 all over 2 times negative 6. That would give you negative 3 plus or minus I root 15 all over negative 12. We could divide everything by negative 1 or break this up into 3 over 12 plus or minus, if I look at it, I root 15 all over 12. And in this case, you would get 1/4 plus or minus I root 15 over 12. Okay. So, remember, number 21, sum is adding them. So what's 6 plus 2i plus 3 plus 5i? Well, 6 plus 3 is 9. 2i plus 5i is 7i. So, letter A would be your choice. Alright, the next one, you know you got to multiply by the conjugate, 8 minus 2i times 8 minus 2i. So right away when I go to do these type of problems, first thing I do is find the denominator. So 64 minus 4i squared would end up giving me, what is that, 64 plus 4, which is 68. It doesn't help me tremendously, right? But I know it's going to be over 68. Now my numerator, if I look, 3 times 8 is 24. 3 times negative 2i is minus 6i. Then minus 40i plus 10i squared. This is going to translate to 24. This becomes minus 10. 24 minus 10 is 14. Minus 46i all over 68. But if you look, all of these can be divided by 2. That would give you 7 minus 23i all over 34, which breaks up into 7 over 34 minus 23i over 34, which ends up being letter C. All right. 23. What would k have to be? Well, think about it. You know 2 times this has to give you negative 10. So 2 times what would give me negative 10? Right? If I plug 5 in here, that becomes 2x minus 5. That's what I want. If you put negative 5 in there, it becomes plus 5, and it doesn't work. So it's letter C. So what is the real part of this next one? A lot of people are going to jump and put 50, but you actually have to FOIL this out to get 50 minus 5i plus 10i minus I squared. Now, you don't really care about this imaginary part, but when I look at it, I get 50 plus 5i, because that's what these combine. Then minus I squared becomes minus negative 1, which ends up being 50 plus 1, which is 51. So the real number here ends up being letter J, 51, because this would simplify to 51 plus 5i. All right. Number 25, for what value of c is x squared minus 7x plus c a perfect square trinomial? Well, I know I'm going to take half of 7 and square it, which would be 49 over 4, which is letter B. What is the max value of the function? Right away you know the vertex is what you need, and the vertex is at the opposite of negative 2 is 2, 6, so your max value is 6. Next one, a volleyball is hit upward by a player in a game. The height of the volleyball after t seconds is given by the function h equals negative 16x squared plus 30t plus 6. What is the maximum height? Right? You know you need the vertex. To speed things up here, when you find the vertex, right, it ends up having a y value of 20. So the maximum height would be 20. You can use a table or graph to find that out. It's probably the quickest way. The next one, same scenario. After how many seconds does the volleyball hit the ground? Right? So if you think about this parabola, you know it's going to hit here. So what is, if x represents the number of seconds or t represents the number of seconds, right? What is the value of x when y is 0? Because that's the height of 0. And it ends up being approximately 2.06 or approximately 2 seconds. 29. What is the greatest zero of the function? Well, right away, if I state x squared minus 25x plus 66 equals 0, I know this is factorable. To find the greatest zero, I'm going to factor it right away to x minus 22 times x minus 3 equals 0. So x equals 22, x equals 3. What's my greatest zero? 22. Remember, 0, x-intercepts, solutions end up meaning the same thing. All right, next here, you have a rectangular vegetable garden that measures 42 feet by 8 feet. You want to double the area by expanding the length and width as shown. What is the value of x? Well, you know the length of this side is x plus 42. The length of this side is x plus 8. Now to find the area, we know we would multiply those together, right? But we know it has to be double the area it currently is. Well, the current area is 42 times 8, right? Which ends up being, the current area is 42 times 8, which is 336. And if we double that, we need this to equal 672. Well, Obviously, you can probably plug these answers in to figure it out, but if you go ahead, multiply this out, set it equal to 0, you would end up getting x squared plus 50x minus 336 equals 0. This does end up being factorable. X plus 56 times x minus 6 equals 0. So your two solutions are negative 56 and 6, but only one of them makes sense, and that's letter B, 6. And the last one. First thing I'm going to do is get rid of this fraction by multiplying by the denominator. So you get z plus 3 all squared equals 35. Take the square root of both sides. Z plus 3 equals plus or minus the square root of 35. Subtract 3. Z equals negative 3 plus or minus the square root of 35. And right away, if I look at my two solutions, negative 3 plus root 35, negative 3 minus root 35 is letter C. Alright, make sure you study and let me know if you have any questions.